close, di sira yung ano, sira puputok yung tubo in case pag hindi ano. Is punta tayo sa ano, sa hydrodynamics. Etong hydraulic jump, actually this partially hydrodynamics. 'Di ba kanina puro pa lang pressure, velocity, ano pa yung sinosolve natin? Pressure, velocity, ano pa? Yun pala naman, yung discharge. Paano pag force? Ito yung ano, ito yung last topic sa hydraulics, yung hydrodynamics. Na kung saan we are now considering the dynamic effects. No, we are considering the force due to the motion of liquid. So this is actually the study of motion of fluid and of interaction of the fluid, which is boundary. Okay? So, of course, ano yung ano niya, ano yung effect niya? So, kung mayroong pipe, halimbawa, yung magtatrabaho diyan sa ano, sa mga kanal or drainage, sewerage, okay? So, may mga truss block na ilalagay pag magkakaroon ng bend, kailangan yan dahil pag may motion, talagang gagalaw yon. May dynamic force. So, ang pag-aaralan natin is yung mga dynamic forces. Una is paano pag flat plates, no? Halimbawa, may jet of liquid tapos may plate. Common is flat, flat. Yung iba is curved, no? Paano pag flat plates? So, dalawa yan. So, may pwede fix, pwede ano, in motion. So, kung babangga yung jet, so magkakaroon ng dynamic effect yon, may force acting. The dynamic force, D is Q, rho Q relative times velocity relative. Sandali, ano ba yung sinasabing Q relative at saka yung velocity relative? Okay. Kung halimbawa, yung meron tayong ano, plate at saka jet. Kung pagtama nung jet, no? So, doon sa plate. Kung ang plate is in motion, ay di yung velocity niya relative is velocity of the jet minus velocity of the plate. If the plate is fixed, then the relative velocity is velocity of the jet. And therefore, the Q relative is area of the jet times velocity relative. Okay? Then that is the equation of your dynamic force. O ganun lang. Now, if you want to, may derived formula kung ipang substitute mo yan in terms of velocity relative squared, pwede rin. No? So, let us say Q relative is area of jet times B relative and times B relative. So, pwede rin ano, yung equation na Q relative, D equals to rho, no? Times Q relative, then times velocity relative, then squared. Pwede ganon. No? Basta pwede. Rho Q times B. Rho Q times B. Pwede na yan. Okay? So, where BP is, VP is velocity of plate and BJ, velocity of the jet. Okay? Paano pag, ano, pag, tawag ito, curve. No? Paano pag curve? Okay? Paano pag curve? Pag curved surface, ang ginagawa natin, if you recall, di ba dati sa statics, paano natin ina-analyze pag curve? Lagi yan by component. Okay? Di ba, napapansin, dadalhin natin yung concept sa statics, pagdating sa dynamics, ganun pa rin. Pagdating sa, ano, sa curved surface, di ba, yan yung total, let us say that's total D. To solve total D, dynamic force against the curved surface, we are solving the component dx at saka dy. And then take Pythagorean theorem. But how to solve dx and dy? So the same formula. Let's say 1 and 2, yun yung section considered curved surface. So dx is rho q relative times b1x relative and b2x relative. Okay? So dy ganun din. b1y relative, b2y relative. In most cases, itong v1 at saka v2 are practically the same pag open flow. Pag closed flow, pwedeng magkakaiba. Halimbawa, pipe system, magkaiba yung diameter. So naiiba yung yung velocity. Okay? Pero pag open flow, normally the same 'yan yung magnitude. Okay? So, 'yun yung pagdating sa curved surface. Ang kinuha natin is component then take Pythagorean theorem. Okay? So, now, V relative is velocity of the jet minus velocity of the kung vane yan, let us say, or plate. Meron siyang plate, no? Basta just remember that the velocity and the dynamic force are okay, it should be meron yang mga sign. No? Dapat pa susunod yan sa tawag ito, yung Cartesian yung tawag ito, coordinate system. Eto pag going to the right, plus b, no? Okay? Ganun din, plus d. Pag going up, okay? So plus by, okay? By yan. Okay? Plus dy. Ito naman, going down, minus by, minus d, okay? Minus dy. Ito naman is minus to the left, so minus bx, then minus dx. Okay? So may mga sign yan, no? Now, etong nakalagay dito na nakalagay na minus, fixed na yan. Okay? Kasi relative ang pinag-usapan natin. So minus whatever the sign of b1 and b2x, b1y, b2y. So dapat sundin mo siya. But itong sa gitna na minus, dapat naka-fix na yan. Alright? So try natin sa problem. May work done din, work done ng moving vanes kung vanes yan. So dx times velocity. Depende na lang sa motion ng vane. Kung dx lang yung motion, then dx times velocity of the vane. Kung dy, kung may motion ng y, then dy times motion of the vane. Right? So, problem. Ito, very simple problem. Actually, this is past CE board exam. A jet of water with a diameter of 250 is flowing at the rate of 0.41 and normally strike the plate. Find the force acting the plate if the plate is at rest. Okay, kung at rest siya. So, wala. Simple, simple at rest yung plate. Di yung relative velocity is velocity of the jet. So, solve ko na yung velocity of the jet, Q over area. Okay, merong discharge given. Then yung area ng tip ng nozzle is 250. So I can solve the velocity of the jet, 10 meter per second. Then therefore the relative velocity of the jet minus velocity of the plate. But the plate is 0, so velocity relative is 10. And the Q relative is also area of the jet times B relative and also 0.491 cubic meter per second. So the force equals to rho Q times velocity relative. So rho is tubig ito. So ano yung rho? So of course 1,000. 1,000 times Q times B. Q is in cubic meter per second, velocity is in meter per second. Ang ending niyan is in anong ending nito? Okay? Ano ba yung force? 'Di ba? Galing ito sa mass times acceleration. Okay? Galing sa mass acceleration. If let us say rho, ano yung rho? Rho QB. Rho times Q times B. Ano yan? yung rho? Di ba? Kilogram per cubic meter times ano yung Q? Cubic meter per second. Ano yung velocity? Times meter per second. So ano yung tawag nito? Ano yung ending niyan? Okay? Ang ending nito is kilogram, tama ba? Kilogram meter per second. Cubic yes, meter per second. Okay, kilogram times meter per second. Second squared. O, di ba? Mass times acceleration. Mass in kilogram, meter per second squared. By the way, ano bang unit nito? Etong kilogram meter second squared, this is in Newton. No? So, the unit is in Newton. So, always in Newton. So, 1,000.491 times 10, that is 4910 in Newton or 4.91 kilonewton. Okay? Then number 2, if the plate is moving at 2 meter per second, so that is the same direction of the jet. Anong mababago? Ang mababago lang is yung relative velocity at saka yung Q relative. So ano yung relative velocity? B jet minus B ng plate. So B jet is 10, di ba? Then plate is 2. So same direction, 10 minus 2. So it's 8. Then Q relative, area of the jet times velocity of the relative. Okay, so I have area is pi times pi r squared. Yung radius is 1 to 5. Squared times 8, that is 0.3927. Then, yeah, substitute na. Ganun na lang siya. Okay. So, we can have dynamic force is 1,000 times 0.9 times 8. Mas maliit na ito. Kasi nag-move na yung plate eh. Parang sinuntok ka tapos umilag ng konti, sabay sabay wag kang go against. Dapat sabay ka lang. Mas less yung force niya. So expect na mas maliit yung dynamic force acting on the plate in this case. So 3.141 or 3.14 kilonewton. So mas maliit na lang siya. Then the work done per second if the plate is moving 4 meter per second same direction. So, ano yung motion ng plate? Towards the same direction. So, the work done is, ano lang siya? It should be the force times the velocity. By the way, how we define the work? The work is force times distance, di ba? But
Force
since
times
this
distance,
is
sir.
force times distance, but it can be expressed in terms of ito, work done per second. So, ano yung work done per second? Kasi ang alam natin yung work is this force times distance o Newton meter, di ba? So, the work is Newton meter per second. So, ang ending nun is Newton meter per second. That is watts. Or Newton meter per second. Newton meter per second is actually force times velocity. So that is also a work done per unit time. Okay? So that is ano lang, kunin mo yung dynamic force, modify mo ng konti, kunin mo yung relative velocity, so 10 minus 4 kasi 4 na ang velocity of the jet. So Q relative, ganun din, times 6.29. So masolve mo yung dynamic force, so 1767 Newton. So ano yung work done niya ngayon if it's moving at 4 meter per second? So we know that the work is the force times the distance in the same direction or velocity in the same direction. So 17 towards the right, and of course yung plate is moving towards the right. So the work should is the dynamic force times the velocity of the plate, and that is 1767 times 4. 706 Newton meter per second, that is actually the work. Per second, Newton meter per second, or simply in watts. Parang ano yung sa kwintador natin, no? Newton meter per seconds. That is watts or kilowatts divide 1,000, no? Oh, by the way, may yung mga metro pala ng ano ngayon, nung Karama, ano, pinapalitan na ng ano, nilalagyan na ng SIM card. Dito sa bahay ko, meron ng ano. Tapos yung trabaho ng mga nagre-reading ng metro. Parang wala ng tao kasi parang may SIM card naka-connect na doon sa ano nila. So, automatic na doon sa ano, tapos digital na yung reading. Ang galing ng ano, galing ng system nila. So, wala na. Automatic na ang bill. Hindi na madi-delay ngayon yung bill. Nandiyan na sa system. Live, ano yung ano nila. Ang galing. Okay? Silipin niyo yung metrohan niyo, baka pinapalitan na ng ano. Dito sa bahay, pinapalitan na no? Kilowatts. Okay? Or watts. Newton meter per second.
Okay. Yun na joules, sir, no?
Joules, pwede rin. Joules is Newton meter. So, Newton meter is joules. 1 joule is 1 Newton meter. Or joules per second, that is actually watts. No? Joules. Si Jolly Joules. Okay? So, paano pag curve, tawag ito? Curve. Ito, bonus lang ito. May solution na, hindi natin i-solve ito. This is just direct substitution. May solution na kayo dyan. So, direct substitution. Lipat tayo sa ibang ano. So, ito pag closed flow. Actually, ito yung board exam ko dati. Oh. No? Paano pag closed flow? Tapos may bend. Ito yung minsan may magpapa-solve. Sa actual na trabaho. Paano yung total force na thrust block? O, di ba? Tapos may pipe. Ito yon. Compute the resultant thrust on the bend. Halimbawa, may bend siya, tapos pipe. So, may flow. 90 degrees yung bend. Ano yung resultant thrust? Okay? So, paano ito? May diameter given. Closed flow, so may pressure. So, ang gagawin natin dito is, ganito lang siya. Okay? Ayan yung pipe. Yung resultant thrust dun sa block, actually, ito yun eh. Ito yung resultant. Okay? So, do not be confused sa ibang reviewer. Ang ginagawa nila, yung resultant na sinasabi is dito opposite, no? Kasi resultant eh. No? So, that is reaction. But the resultant, it should be in this direction. Di ba? Mechanics, resultant force. A resultant of all the forces. When we say find the reaction, of course, the reaction is in this direction. The same, opposite to the resultant. Alright? Okay, makita nyo sa mga kay Bisa, kay Gilisanya na solusyon, ang R, ganito na ang direksyon. But ito, sa akin, is dito na pa resultant. Okay? Ginawa kasi nila, pinagbaliktad yung, yung formula. But will be consistent always sa formula. Basta resultant, actual yan, dun sa na nag-act. Ano yung R na yan? Again, solve natin yung mga component ng Pythagorean theorem. Alright? So, ganun lang siya. Okay. So, anong gagawin? Kung ito closed flow yan, so meron yang kung i-cut mo yung cross-section, tingnan mo sa ilalim. So, under pressure yan, di ba? So, i-cut mo yung section, ano mangyari niyan? I-cut mo siya. Oops. Section 1 and 2. Putulin mo yan. Okay? So, may makuha kang, of course, the resultant. I-cut mo yan, putulin mo ngayon, no? Putulin mo yung pipe. Tanggalin mo yung mga, kunwari, yung mga tornilyo. Okay. Naka-flange yan, di ba? Normally. Then, pag tanggalin mo yan, expose mo yung pressure. May pressure yan, P1 at saka P2. Di ba? So, kung maliit lang yan na bend, so expect na yung pressure P1 at P2, tapos laid yan horizontal. Kasi, ito nakikita natin, plan view yan ha. Sa plan view tayo tumitingin. Okay? So, of course, parehas yung pressure. Bend lang yun eh. So, yung 1 at saka 2, parehas yung pressure. Okay? And net pressure is 210. No? Sometimes yung meron siyang bend tapos at the same time meron pang tawag nito, yung magkaiba pa yung alam mo yung reducer. Okay, magkaiba yung diameter sa 1 at saka yung 2. So gamitan mo ng Bernoulli equation 'yun para ma-solve yung pressure. Di ba? Kung may head loss or wala. Kung walang head loss, di pwede ayos lang. Parehas yung pressure. Okay? So neglecting head loss, parehas yung pressure. So, yung P1 sa P2, you can solve the total hydrostatic force. Pwede yung ma-solve yan. Those are all static. No? F1 at saka F2. To solve F1, P1 times area. Tama? F2, P2 times area. So that is P1 times area. So, 210 times 0.15 squared times pi. That is 1484 kilonewton. F2, ganun din. Opposite direction lang. F1 and F2 parehas. Neglecting head loss, same pressure, FP1 equals to P2, F1 equals to F2. Parehas yung diameter kasi. Now, dynamic force, ito yung dynamic force. Yung dynamic force, hindi yung R ha. R is the resultant. Dynamic force is dx Q, of course, rho Q relative times B relative. No? So, in this case, B1 and B2 parehas kasi parehas ng diameter. No? So dy ganun din, no? Component. Saan yung dx and dy? Ito 'yon, dx dy. Okay? Okay, ito yung dynamic force. So ngayon, solving dy and dx, kailangan ko yung bx at saka b1x at saka anyway, b1 and b2. This should be equal kung the same diameter. So, pati yung relative velocity niya. Anyway, what is relative velocity now nung b1? Since yung pipe is static, relative dun sa surface, kung ano yung flow. So, 0.23, divide mo lang ng area. So, you have b1 and equals to b2, 3.25. Di ba? So, ngayon, that is now our relative velocity. Bakit? Kasi yung pipe mo hindi naman nag-move. So yung surface hindi nag-move. So yung B relative is also equals to 3.25. No? Okay, so now after that, then maso-solve mo na yung B1x and B2x. For dx, yung 1 at saka yung 2, mapapansin mo, 'di ba? Dapat B1x minus B2x relative. Yung B1x, ano yung B1x? 'Di ba ito 'yon? Directed in this direction. Yung B2 is in this direction. Ang B2x is 0, pero yung B1x is 3.25. Di ba? Okay? So, ganun yun. So, kaya 3.25 minus 0. Ay, masolve mo yung dx. Okay? 0.747. Yung dy, ano yung dy? Ang d1y mo is 0, b1y is 0, ang b2y is 3.25. Okay? Mapapansin mo, paano naging 0 yan? Kasi at point 1, asan ba yung point 1? So yung point 1 mo is nandito. Nandito yung 1, nandito yung point 2. Di ba? So ano yung y mo? Ang y mo is 0 kasi directed towards to the left yan no? At that section. 0 yung y. Pero dito sa 2, di 3.25 upward. So, positive. No? 3.25. So, 0 minus 3.25. Masolve mo yung dy. No? Practically the same. Okay, nga lang, negative. Di ba? Mapapansin mo, meron niyang sign. Yung dx mo positive, that is to the right. Yung dy mo negative, ibig sabihin that is downward. Okay? So, ibig sabihin, downward yung y, dy, tapos yung dx is to the right. So, taking the resultant, so yung rx ko ngayon is summation of f1 at saka yung dx. Yan yung rx ko. Di ba? Now, yung may f1 ka na, you can simply add. No? That is 15.59. Yung ry, summation of forces y. Ano yung forces y? Downward, F2, at saka downward, dy. Okay? So, these are all minus F2. Sandali, bakit mo nilagyan ng minus F2? Kasi sabi ko kanina, yung mga forces, meron yang sign. Kung downward, minus. Kung upward, plus. To the left, plus. Minus. To the right, plus. Okay? So, F2 is downward, dy is downward. Okay? So, i-add mo lang siya, 15.59. Mapapansin mo, ito na yung itsura nun. Okay? Yung Rx is positive. Yung Ry is negative downward. Okay, 15. But the same magnitude. So therefore, the resultant, take the resultant, that is Rx squared and Ry squared. Yeah, you can solve 22.004 kilonewton. No? So ngayon, ito. Okay. Ano? Ganun lang. Yung exam ko minsan. No? This is a case of closed flow. So, medyo matrabaho ng konti pag closed flow dahil isosolve mo pa yung static forces. Okay? Pag curve tapos open flow, katulad ito, merong vanes, yung mga vanes. Okay? Yung mga para sa mga turbina, no? Yung deflected surface, short surface. A jet of diameter 50 mm and velocity of 12 is deflected through an angle 60 by a fixed curve vanes. Neglecting friction, determine the horizontal and vertical component of force. If the vane is deflected at 180 degrees, determine the force, total force exerted on the vane. Ito yung horizontal and vertical component. This is the case of open flow. No, unlike yung kanina, may pipe, tapos may pressure. Ito, walang pressure. Right? So, ano lang siya? Open flow. Okay. So, now, okay. Ganito. In solving dx, dy, ganon din kanina. Component. Okay? So, ito yung vane. So, short curved surface. So, velocity of the vane is, the first case is fixed curve vanes. So, 60 degrees. So, yung D is yan. Tapos, of course, we cannot solve directly the D. By the way, ang hinahanap nito is yung component dx and dy. If you want resultant, then take Pythagorean theorem. However, kahit na, no, kailangan component lang lagi ang sinosolve natin dx and dy. Okay? So, solve dx and dy. So, dx, same formula kanina. So, meron kang 0.1 at saka 0.2. In this case, yung 0.1 mo, normally at the start entrance ng vane. Okay? Yun yung 0.1. Okay? And yung 0.2, of course, yung sa exit side. So, ito yung 0.2. No? Okay? So, velocity of the relative is jet minus velocity of the vane. So, meron tayong velocity of the jet, 12, and velocity of the vane is 0. So, relative is 12 meter per second. So, ganun. So, then you solve the dx and dy. Direct substitution. Q relative is relative jet times velocity relative. Meron kang 50 diameter times 12 meter per second. You can solve the Q relative 0.026 cubic meter per second. Then you can solve the dx and dy. Take note, the sign. dx tayo, di ba? So, ano ang direction ng anong direction ng 1, d1? Kasi b1x, di ba? Ito to the right, horizontal, so positive. Dito to the right, but angle 60 degrees, so yung x niya is lahat positive. Napapansin nyo, ito is positive, ito is also positive. Etong minus na to, as sabi ko kanina, kasi relative tayo, ito is lagi yan minus. Alright? Mamaya, mababago yan. Tingnan natin. Then, you can solve dx and you can solve dy the same. So, yung dy is b1y minus b2y. Mapapansin mo dito at 1, 0 yung, 0 yung b1y kasi at 1, horizontal yung direction. Pero at point 2, aba, meron na siyang upward pa rin. So, minus 12, positive 12 sine of 60, yung component ng B2. Okay? So, as napapansin mo, yung B1 ko at saka B2 relative, practically the same. This is an open flow. Okay? So, parehas sila. Ngayon, so yun yung yung sagot, D1, dy, and dx. dy is downward, dx is to the right, 142. What if the vane is deflected 180 degrees? Okay? O ganyan. Paano pag ganyan na? Okay, ganun pa rin. Ang kagandahan nito, walang y component. Klaro naman yan, isa lang yan, di ba? So yung dynamic force, dx. D equals to dx. So dx equals to rho b1 relative at saka b1x minus b2x. So mapapansin mo, kung sabihin kong ito is 0.1, okay, 0.1, ito is 0.2. Okay? So ngayon, ito yung velocity dyan, b1, at saka dito is, ito yung velocity 2. So, opposite direction. Mapapansin mo, opposite direction na yan. So, ngayon, so yung dx ko is magiging, 12 yung b1, di ba? So, yung b2, ganun din, 12. So, magiging 12 minus, but negative 12. Di ba? So, kasi salungat salubog. So, expect na mas malakas. Kasi nag-deflect Mas malakas yung dynamic force. So, 12 minus of minus becomes positive. So, may makuha kang dynamic force 566.4 Newton. Right? So, ganyan. Basta tandaan nyo yung formula B1 minus B2. Huwag malito sa ibang libro magiging B2 minus B1 yan pag yung resultant yung kinukuha. Basta yan lang lagi, B1 minus B2 and just follow the direction, yung sign. Yung sinasabi ko kanina plus and minus direction of forces. Okay. Ito magandang magandang tanong. Paano pag ganito? Walang problema. Ganun pa rin. Halimbawa, merong water jet tapos hinati, no? Parang tinusok ng ng plate tapos naghihiwalay. So ang sabi dito, water jet shown in figure is moving at 13.72. So 13.72. So napunta sa A, napunta sa B, pero yung speed parehas lang 'yan. Na magkaiba yung quantity ng flow, pero yung malamang yung yung velocity parehas. Okay? Is split so that 1/3 of the water moves towards A, assuming ideal flow. So when you say ideal flow, that is a fractionless flow. There's no head loss. Compute the horizontal component of the force on the stationary splitter. Yung horizontal component. Okay? Magnitude of the resultant force and the magnitude of the force on the splitter if the splitter moves 2 meters per second to the right. Ay, magandang problem ito. So, ganito. Yung number 1, horizontal component of the force on the splitter. Kasi ang force nito is pwede ang resultant is pwede ganito. Pero ang hinahanap lang is yung horizontal component. No, yung total. Since dalawang curve. So may isa diyan, may isa dito. Kunin mo yung component na yan. Yung dalawang horizontal component. No? Alright? So, okay. Paano siya? Ganito. dA at saka dB. No? Component ng dx at saka dbx. Take the sum. So that is the horizontal component of dynamic force. Ayan, di ba? So, unang-una is kunin mo yung relative velocity of the jet. The plate is fixed. So, the relative velocity is equals to the velocity of the jet. So, Q relative is area times velocity relative. Therefore, this is 0.01 yung area. Yung area ng jet, 0.0139 times 13. So you have Q 0.19. Di ba? Tapos sabi, 1/3 daw towards A. So 2/3 yung nasa B. Okay? So Q relative is area, okay, A at saka B. Ang total niyan is 0.19. So 1/3 of 0.19 is 0.06. So 2/3 is nung sa B, 0.19. So that is 0.12. So nahiwala yung amount of water. So ngayon, subject mo lang. Fx is, okay, summation of dx. Okay, A relative, no? Area A, velocity A relative is velocity B relative. That is 13.72. Ideal flow eh. Okay? So, pares uniform yung speed. Uniform yung speed. Okay. So, dx is rho q times b1 minus b2x. Ganun na lagi. Anong nakita nyo? Anong naiba sa solution? Ito lang, naiba lang yun. Ito lang, But still, the velocity, parehas 13.72. So, when we're saying dx, ano yung dx? Ito yun, di ba? Ito yun, dx, ito. Okay? Ito yan. Ito siya. dax. Ito yan. dax. So, ito yung start, then ito yung end. Ito yung start nung tapos ito yung end. Tapos sa kabila, ito yung start, then ito yung end. So, ganun yun. So, may angle 60 degrees, di ba? Di ba? 60 degrees. So, ibig sabihin, sa start pa lang nung sa start sa A tayo, ay horizontal yan. Dito yan. Okay? 13.72. Pagdating dito sa end, wala na. To the left na, and that is cosine of 60. Component nito, ang component nito is cosine of 60. 60 degrees yung ano eh. Ayan, sige. So, cosine. So, negative in the left towards the left direction. So, napapansin mo, mayroong negative sign. So, magiging minus, magiging plus. Yun yung dx. And yung dbx, ang dbx naman is 13.72 minus 13.72 cosine of 60. So, yun yung Ang naiba din is yung discharge. Naiba yung discharge. Pinaghiwalay kasi natin eh. Okay, di ba? Then, just add the total dx. dxa and dxb. So you can solve the total horizontal force. Okay? And that is 13.02 and 869. So ganun lang. Although medyo sa tingin mo parang mahirap. But kung intindihin mo, ay ganun lang pala, ang madali lang. Individual. Summation of individual component of the dynamic force. Alright? So, ganun. And yung kasunod na tanong is compute the resultant force of this on this stationary splitter. Kung resultant, meron ka ng fx, isusolve mo rin yung fy. So the same flow, instead na x velocity, papalitan mo lang siya ng y, no? So, may fx ka na, solve mo yung yung tawag nito, yung y, dy at saka dx. So, magiging nito, 0 kasi at 1 horizontal yung yung at the start. So, 0 yung y, pero dito sa yung end, yung y niya is downward. So, towards downward, mapapansin mo na may negative kung ang nilagay. Kasi downward yan, yung velocity. Pag upward, positive. So, ngayon, dy is 752.12 dy. So, the same flow nung solution. Ma-solve mo yung sa dby. So, mapapansin ko, start is 0, but doon sa taas, since that is towards upward, minus of positive. Napapansin mo, minus 13.72. Di ba? So wala nang other negative. Kasi that is towards, papunta sa taas yung velocity. So may makuha akong dBy, that is 15, 1505, that is directed downward. And of course, pag samasamahin mo lang, take the net. So ang dA is to pataas, but yung dBy is pababa. So yung net ang kukunin mo diyan. O di minus 753. Okay, so therefore, the resultant is fx squared and fxy squared, and take the square root. You can solve the resultant force, 2298 Newton. Di ba? Medyo, kung isipin mo, parang medyo mahahaba, pero look at the flow of the solution. Ano lang siya? Madali siyang intindihin. Okay? Kasi consistent tayo sa equation natin eh. Lagi yan, rho Q relative, V1 relative, V2 relative. Okay? Then find the force on the splitter if the splitter moves 2 meter per second to the right. O di kung nag-move ang splitter, ano mangyari niyan? So, anong twist nung sa solution? Ganun lang din, mababago ang kung nag-move yung splitter, mababago lang ang V relative. Okay? Mababago lang ang relative velocity. Okay? O, ayan. Instead na 13.72, lahat ng previous solution mo, papalitan mo lang siya ng 11.72. So, ganun lang, no? Okay. So, yun. Papalitan mo lang ng 11.72 kasi nag-move siya to the right. So, ngayon, ang Q relative, ganun din. Mababago ng konti, mababago ng konti. So, konting twist pag nag-move ang ng splitter. So, ang QA at saka QB mag-change. So, ganun din. Then, FX, FY, then take the Pythagorean theorem. So, konti lang yun, konting twist. Yun lang yung velocity relative at saka yung bago yung value ng Q. Ang effect nito is liliit yung makukuha mo yung makuhang force kasi nag-move ang splitter. So, ito yung na instead na 13.72 magiging 11. Instead ito kanina hindi ito 0.54, ibang value nito. So, nababago ng kunti. Iba yung fx. Pati yung fy ganun din. So 11.72 at saka ayan. Ganun lang. Ayun yung changes, kunting change. Na napapalitan lang yung q at saka yung relative value of relative velocity. Kung mag-move ang splitter. Okay? So yun yung yun yung twist ng magandang problem. Medyo mahahaba. Pero pang board exam, pwede hindi naman lahat. Isa lang ang tinatanong diyan. Pwedeng isang find fy, find fx, then find the yung 3 unknowns, 3 equation. Find the total resultant force. All right? So we still have time. Okay, we'll move to other possible question. Na itong may minsan lumalabas, kahit itong bago lang nakita na akong water hammer, konting lang, it's just simple substitution sa formula. Itong water hammer is just ito, ang definition is momentary increase in pressure inside pipeline caused by a sudden decrease or stoppage of motion of liquid. So yun yung water hammer. So kaya 'di ba tingnan mo sa lababo or yung water heater pag mag-on and off ka dun sa So may ingay. Pero maiiwasan yung ingay na yan pag lalagyan mo ng water hammer arrester. May mabibili na nilalagay. Parang shock absorber, no? sudden stop nung flow of yung bulb. Okay? So, yung iba, nilalagyan talaga ng tawag nito. Di ba may maraming klaseng gate? Yung bulb, float bulb, gate bulb. Actually, hindi ako kabisado. But alam ko may ball bulb. Yung mag-automatic shut off siya. Pag mag-stop yung flow. Okay? So, but itong water hammer, ay ibang ito, is the sudden increase. Kaya nga sinasabi momentary increase in pressure. If sudden closure of bulb. Pero kung mawawala yan, kung talagang dahan-dahanin mo, kung gusto mong walang shock, okay, di dahan-dahanin mo. No? Parang mangliligaw ka rin, di ba? Para hindi ma-shock yung dahan-dahanan mo lang. Okay? Wag diretso. No? Para wala yung sinasabing shock. Okay. So, parang ito siya, no? Ang water hammer is ito. Kung may motion ng liquid, ganyan, pag tama noon, ang ibang tawag ito yung sinasabing celerity, yung pressure wave. Yung balik noon, okay, that is yung sinasabing celerity. It's actually, yung wave na yon, parang equivalent sa velocity of sound, no? Celerity. Kasi para siyang formula square root of yung it's a function of elasticity and the density. It's the same yung sa mga acoustic board. Bakit acoustic board? Yung nilalagay sa sa mga FM station. Kasi yung niyan is mag-absorb yung hindi mag-rebounce. Hindi siya rigid. Pero pag rigid, ang mangyari kasi may magkakaroon ng magre-rebound. So, yun yung similar lang yung sinasabing celerity, yung formula ng C. Okay? So, yung water hammer, ito yon. Nag-flow yung tubig tapos biglang close, di sira yung sira, puputok yung tubo in case pag hindi makakayanan, hindi na design ng husto yung thickness. Okay? So that is water hammer pressure. Okay? So may water hammer arrestor. Actually, yung nilalagay sa ayun parang siya, alam mo yung ng tubig, yung filter. So kasi may spring sa ilalim yan. Tapos pag biglang stop, so mapupunta yung pressure doon sa sa spring. No? I-absorb nung spring. So parang hindi mo mapapansin na walang tunog, walang ingay. Yan, nilalagay yan. May mabibili na water hammer, tawag yan water hammer arrestor. Para maiwasan yung pressure shock wave. Anyway, yung formula ng sa board exam, direct substitution lang ito. Yung formula ng non-rigid pipe, ito yung mahaba. Ito madugo. Okay? Pero pag rigid, pag sinasabing rigid, yung ito yung sa mga pipes yan, non-rigid, medyo elastic siya. E over rho, then 1 plus E, B over E, then diameter and thickness. So, ano yung mga sinasabi na yon? Mamaya ito yon. The diameter of pipe, thickness of pipe, then elasticity of fluid, yung EB, tapos elasticity of pipe, yung E. So, yan? Kaya pipe at saka yung elasticity of pipe at saka elasticity of fluid. If yung rigid pipe, yung E is rigid. Okay? For rigid pipe, na kung saan, yung elasticity is compared to water or yung fluid, sobrang laki. So, mapapansin mo, if yung E is sobrang laki, so yung denominator, mapapansin mo yung denominator, malaki, di ba? Kung malaki yung denominator, no? If E is more than elasticity of fluid, di yung ratio nitong EB times D over E times thickness is close to 1. Close to 0. Right? So therefore, ang equation magiging E over rho pag rigid pipe. Kaya ito yung sinasabi kong celerity. ito din yung ano, yung equation sa yung ano, yung sa survey, yung sa mga hydrographic survey, yung velocity of sound underwater. Ito din yung formula. Elastic water tapos density. Yung sinasabing celerity or pressure wave. Ganon, pressure wave. Then tawag nito, yung formula ng increase ng pressure, lagi yan, celerity at saka yung velocity lang. Tapos density, diyan lang iikot. So yung formula is ito. Round trip time TR is 2L over C. Mapapansin mo dito yung round trip time, yung sabing round trip time. Okay? So, yung ano kasi, yung asan ba 'yan? Okay? 'Di ba? Galing dito sa source tapos bumangga dun sa bulb tapos bumalik. So yung round trip time nun is 2L over celerity. Okay? So yung sinasabing round trip time. Dito masosolve mo yung ano, kasi may type of ano kasi, may type of closure. It can be instantaneous, it can be, rapid or slow. So didepende sa time of closure. Iko-compare mo yung time of closure at saka yung round trip time. Yung round trip time is 2L over C. So if time of closure is 0, so biglaan, as in immediate. Malaki yung pressure niya. Rho C times B. Yun increase yung pressure of pipe. Then if rapid closure, if time of closure is less than round trip time, no? So medyo mabilis, but ganun pa rin halos yung increase of pressure. Rho times celerity times B. So rapid or instantaneous, parehas lang. Pero pag slow closure, alam mo yung daan-dahan, yung time of closure is mas greater than dun sa round trip time, mas maliit yung yung pressure. Kaya may kunting correction lang. Rho CB times TR over TC. Ganun lang yung direction of motion. Ang problema lang is at least alam mo itong alam mo yung mga cases. Kasi yung celerity, madali lang. Yung velocity, madali lang. So it's just a matter of knowing yung cases of closure. Okay, halimbawa, ito is actually past board exam. Celerity such that the pressure wave is 975 meter per second. The pipe diameter is given and the bulb located 600 meter downstream. Water is flowing initially at 0.85 meter per second. Find the water hammer pressure for instantaneous closure. Ito yung sabi ko kanina, instantaneous. So, rho CB lang siya. Rho times celerity times B. Yung celerity, given 975. Yung rho, tubig ito, 1,000. Kailangan ko lang masolve yung velocity. Di may Q, may area, di masolve ko yung velocity. So, direction ito siya. No? So, rho CB. So, velocity is Q over A. So, this is 0.75. Rho is 1,000. Celerity is 975. So, we have 1,975 times 0.75. This is Pascal. Okay, Pascal ang result niyan. Newton per meter square. So that is, or in kilopascal divide 1,000. Yung isa is, what is the water hammer pressure if it's close in 4 seconds? So kung ganito, hindi natin alam kung rapid or slow, we need to solve the round trip time. So solving first the round trip time, 2L over C. So L is 600. So 2 times 600 divide 975, 1.23. So what is the round trip time? 1.23. What is time of closure? 4 seconds. So mabagal. Okay? Mabagal yung time of closure. Dinahan-dahan. Okay? Dinahan-dahan is slow closure ito. Alright? So therefore, ito yung rho CB times TR over C. So mas maliit yung yung water hammer pressure. So this becomes 2 to 4.8 kilopascal. What is the water hammer pressure if the valve is manipulated so that the water drop almost instantly? Ito may mga magic daw. So almost instantly from 0.85 to 0.28. What is the water hammer pressure? Flow rate drops from 0.85 to 0.28. So anong gagawin natin? I-solve yung, okay, time of closure is 0 instantly. Hindi naman sinasabi yung pag-drop na yun. So closure is 0, ang mababago na ito is yung velocity. Okay? So B2 is 0.28 over area and therefore 0.25. Rho CB lang pa rin. So the change of velocity is from 0.75 to 0.5. So change instantly. What is the water hammer pressure? So the change in velocity now becomes 0.5 meter per second. So nag-drop lang siya so 2.28. So change in V is 0.5 from ano ito, from 0.85 to 0.28. So yung final velocity, yung B2 is 0.25. So ang kailangan nating makakuha ngayon is kasi water hammer pressure, minamagic actually from 0.85 to 0.28. So yung change in velocity ang pag-usapan natin. So yung delta. So yun yung gagamitin natin doon sa pagkuha sa change in water hammer pressure. Okay? So rho C times delta B, and that is 487 or 487 kilopascal. Okay? So yun yung ano, so far yung minsan pinabaliktad-baliktad lang. Minsan may board exam na ikaw pang kukuha ng celerity. Mas mahirap pag ikaw pang kukuha ng celerity tapos paggamit mo yung equation, yung kahaba-habang equation. Alright? So pero pag binigay na yung celerity, wala na, dali na lang. Hindi masyadong ma-problema. Okay? So that is water hammer. Okay, so last minsan is yung drag force. Actually ito HydroDynamics ito yung sa drag force or lift force. Is a lab 3